Welcome to Study Time, a televised home learning program produced by Rwanda Education Board.
Hello students, welcome again to the TV learning program. I hope you are all doing well. In the previous lessons, we discussed the carbonyl compounds, how we name carbonyl compounds, the physical properties of carbonyl compounds, and today our lesson will focus on the preparation methods of carbonyl compounds. I hope you all remember the meaning of carbonyl compounds. It's the aldehydes and ketones. But before we start our today's lesson, I want you to try this revision exercise. Complete this equation. We have one equation here to be completed. Complete this equation, and when you will be done, you will try the second question: how can you synthesize propanone from 2-chloropropane? You prepare propanone from 2-chloropropane. Well done. So let's have a look at the answers of these two questions, the revision questions. You remember we have also studied the chemical reactions or the reactions, the chemical properties of alcohols. We have discussed the oxidation of alcohols. Do you remember what we get when we oxidize an alcohol? An alcohol like ethanol. When we use an oxidizing agent like this one, we produce an aldehyde. You did it well if you have this answer. But this is a strong oxidizing agent, and because of that, it is not very simple to produce the aldehyde. Instead, if there is some oxidizing agent remaining, we will produce an acid, a carboxylic acid. And this means that the aldehyde we produce will undergo a further oxidation, and we produce CH3COOH. The class of compounds to which this one belongs is called the carboxylic acids. And how can you synthesize propanone from 2-chloropropane? We have many methods, and that is the most interesting thing in organic chemistry when it comes to the preparation of organic compounds. There are several routes you can follow and you get the same compound. So let me show you the one I've suggested. We can see that this compound can be produced from an alcohol as it contains an oxygen atom. You remember the oxidation of secondary alcohols. When we oxidize secondary alcohols, we produce ketones, right? And when we oxidize primary alcohols, we produce aldehydes. So this one being a keton, we can think about preparing it from a secondary alcohol. And if we have to use a secondary alcohol, let us see if there is a way we can convert this one into an alcohol. Do you remember the chemical properties of alkyl halides, halogenoalkanes? Yeah, you do. So from this alkyl halide, we can use aqueous sodium hydroxide to transform it into a secondary alcohol. How is it done? We have this reaction. CH3CH, chlorine, CH3, we add dilute sodium hydroxide, Remember, we have to reflux to avoid the escape of some reacting substances, and we get CH3CHOH, CH3 plus sodium chloride. Now we have our secondary alcohol, and the secondary alcohol can be oxidized to produce oxidation to produce the ketone we wanted. So this is one way of preparing that ketone using 2 steps. And how is this connected to today's topic? You can see here we have prepared a ketone. So from the previous lessons, we have seen so many reactions which can be used to prepare ketones and aldehydes. And those are the reactions we are going to be discussing today. Which reactions have we seen that can be used to prepare carbonyl compounds? Here we have an example. From an alcohol, we can prepare a ketone. So there is a way of preparing ketones and aldehydes when you start from alcohols. Preparation of carbonyl compounds from alcohols. We can start from alcohols, and when you oxidize a primary alcohol, here we have a primary alcohol. You remember the classes of alcohols: primary, secondary, and tertiary. So when you start from a primary alcohol, you produce an aldehyde. But this, as I said, from our exercise number 1, it will depend on the oxidizing agent you are using, because some of the oxidizing agents are so strong. They are so strong that the oxidation will undergo a further step to give you a carbonyl compound. So you have to be very careful. What oxidizing agents can we use here? To convert our alcohols into ketones and aldehydes, you can use potassium dichromate in acidic medium or basic medium. You can use potassium permanganate in acidic medium. And here, if you use these oxidizing agents, the common ones we know, and you want to start from a primary alcohol and produce an aldehyde, you have to remember this. You have to distill of the product as soon as it is formed, and you work under a low temperature. In that case, you can collect the aldehyde which is being produced. So from a primary alcohol, you remember the meaning of this ara. This ara stands for an alkyl group. It can be replaced by CH3. It can be replaced by CH3CH2. Any alkyl group can be in the place of this ara. Okay? So from primary alcohols, we can oxidize, and you have to remember to distill off and work at a lower temperature so that you can collect the aldehyde which is produced. If you don't distill off the mixture or the product, that aldehyde, as soon as it is being formed, know that it will undergo a further oxidation to give you a carboxylic acid. What do we get when we use a secondary alcohol, like this one? A secondary alcohol can be, let us take the example of this one. This is a secondary alcohol. And the one we have used here is a primary alcohol. So when we use a secondary alcohol, we produce a ketone. a ketone just like this one, propanol. Okay? And for the oxidizing agents we are using here, we produce ketones which cannot undergo further oxidation. And here there is something very important. I want to remind you. From tertiary alcohols, there is no reaction. You know the reason why there is no reaction. It's because this carbon here, it lacks a hydrogen atom. So with no hydrogen atom on that carbon, there is no possibility of undergoing an oxidation. And that is the reason why, in some cases, we can use the oxidation reactions to distinguish alcohols. You remember the chemical properties of alcohols and the chemical tests of alcohols. We can use oxidation to distinguish the different classes of alcohols. We can also prepare carbonyl compounds from alkenes. You remember the class of alkenes? The alkenes are those ones containing a double bond, carbon-carbon double bond. So we can use a reaction which is called ozonolysis. And we can also use the common oxidation, where we use these two oxidizing agents. What do we get when we when we use alkenes and we carry out ozonolysis? We have the reactions here. Reaction number 1 and reaction number 2. If you use an alkene which has the hydrogen and hydrogen on the 2 carbon atoms of the double bond, you will produce aldehydes. But if you use an alkene which is completely substituted on the 2 carbon atoms making the double bond, you produce 2 ketones. Here we can give the example of CH, 3CH, CH, and CH3. The 2 carbon atoms of our alkene are hydrogenated. So if we use O3, that is ozone, in the presence of water, we produce 2 moles of CH3CHO, ethanol. Why are we producing 2 moles and not 2 different substances? It is because we have a symmetrical alkene. You can see the 2 parts on both sides of the double bond are similar. So if you use a compound like this one, CH3 and CH3, what do you produce? You produce CH3CHO plus CH3CO, CH3. Now we have an aldehyde and a ketone because the carbon here is completely substituted, so we produce a ketone, and the 2 parts on both sides of the double bond are different, so we produce 2 different compounds. I think it is very clear. And I said the second way of preparing these compounds from alkenes, it is to oxidize the alkenes by using our known oxidizing agent. It is almost similar to this one, but we have one difference. The difference is that here the double bond is broken. The double bond is broken. And something similar is that you have to make sure you distill off the product as soon as it is formed, because if you don't do that and you are producing an aldehyde, it will undergo a further oxidation. But for ketones, don't worry. It just stops at the formation of ketones. Now, let us have a look at the second or the other methods of preparing ketones and aldehydes. We can also start from the alkenes. alkynes. Here we have the hydration of alkynes. Alkynes react with water in acidic medium and presence of a mercury salt as a catalyst to produce carbonyl compounds. And here you can see what I'm saying, the acid and the mercury salt, the water we add, and the OH. Do you remember the Markovnikov rule? Yes, you remember it. So the OH goes to the carbon, which is less hydrogenated, and the hydrogen goes to the carbon, which is more hydrogenated. And we produce this compound, which we call an enol. Enol means what? It means that we have a double bond and an OH group. So it is a combination of the alkene and alcohol functional group. And because of being in equilibrium with this compound, then it transforms itself, or because of being less stable, it transforms itself in the more stable ketone. So when we use an alkyne, react it with water, we produce ketones. The only alkyne which produces an aldehyde is ethane. Ethane is the one with 2 carbon atoms. So when we use it, we produce ethanol. It is the only alkyne which can produce an aldehyde. All others will always produce ketones. There is also a possibility of carrying out an anti-Markovnikov addition. So what we are doing here is the Markovnikov addition. But do you remember in alkenes what we call hydration via hydroboration? Yes. We use boron hydride, this one, and in the presence of oxygenated water or hydrogen peroxide, and in basic medium, what do we produce? We produce an anti-Markovnikov product. Here it is saying that the anti-Markovnikov product means that we will place the hydrogen on the less hydrogenated carbon. It's here. See, this carbon is the one which has taken the hydrogen. So this is anti-Markovnikov product. And when it undergoes a rearrangement to produce the more stable carbonyl compound from an enol compound, we produce an aldehyde. So if you want to produce aldehydes, always you can use hydration via hydroboration. Let us take some examples. CH3CH, CH plus H2O in the presence of an acidic medium and a mercury salt. What do we produce? We produce CH3, CO, and CH3. Remember, the first product, the intermediate product, is an enol, but which will immediately transform itself to give us a ketone. If we use ethane, remember, we will produce ethanol. And we said by producing the Markovnikov products, it is the only compound which will give us what? Which will give us an aldehyde. And if we take CH3, CH3 plus BH3 boron hydride in the presence of hydrogen peroxide, and in basic medium, what do we produce? We produce CH3, CH2, and CHO, propanol. So that is what we get when we use the anti-Markovnikov way of preparing aldehydes and ketones. And those are not the only methods we can use to prepare these compounds, because we have 2 more methods, or even 3. So we can start from compounds we call acid chlorides. Acid chlorides, they are derivatives of carboxylic acids. And when we use them, this is an acid chloride. And you know this class of compound, we call them organometallics. They are organic compounds, the alkyl halides, but which contain magnesium as a metallic element. So they are called organometallics. So the organometallic can react with an acid chloride to give us a keton. What happens? This ara, it contains carbon. The example can be CH3Mg chloride. Remember, magnesium is less electronegative than carbon. So being less electronegative than carbon, it carries a partial positive charge, and here we have a partial negative charge. It is the same here. For this carbon, we have partial positive charge because it is connected to what? It is connected to this oxygen, which is more electronegative. So we get this. The partial negative part will attack this one while the bond will open. And we get oxygen, which has a negative charge, and the magnesium with a positive charge. But this one will immediately undergo a rearrangement to reform the double bond here, and this bond will be broken. And as it breaks, we produce Cl negative, which will go with MgX, which is positive, to combine and give us this ionic compound. And then as the double bond reforms, we will produce the keton. It's very clear. So you have the example here, CH3MgCl reacting with propanyl chloride. This compound is called propanyl chloride. We get bitanone and magnesium chloride. Bitanone and magnesium chloride. It's very simple. And what do we get when we reduce acid chlorides? It is also possible to prepare carbonyl compounds by reducing acid chlorides. There is something to be noted here. When you use organometallics and acid chlorides, you always produce ketones. And when you use the reduction of acid chlorides, you will only produce what? You will only produce aldehydes. So here we have the production of an aldehyde and a chloride ion by starting from an acid chloride. We always use this hydride. You have to remember that hydrides can be produced from lithium, aluminium hydrides, but because those ones, the common ones like lithium, aluminium hydride, the one we know is this one. It is a strong reducing agent which cannot give you an aldehyde. So we use some other weak reducing agents. Now let us have a look at the last method, but of course not the least. We have it here. We can start also from nitriles reacting with organometallics. A nitrile is a compound like CH3C triple bond nitrogen. So it is a compound containing a triple bond between carbon and nitrogen. So the carbon here is partially positive and the nitrogen is partially negative because of being more electronegative, and it is like this because of the same reason. So there can be an attack on this carbon from the partial negative part of this organometallic. We get this intermediate with a negative charge and a positive charge on this part. When this intermediate is hydrolyzed, Hydrolysis means reacting it with water. We produce this amine. These are called amines. But it is also an intermediate product which will give us the ketone we have here once it is also hydrolyzed. So we can take the example of CH3CN. If it reacts with CH3, for example, Mg chloride, and we work in acidic medium, we use 2 moles of water, what will be produced? We will produce a ketone, and the ketone will be this one, CH3COCH3. It's very simple, plus NH3, and some other byproducts like ClMgOH. Okay? Yes. Now, I think that everything has been explained very well, and you have understood each and everything. And before we stop our lesson, I want to give you an assignment. You will try this exercise. How can you perform the following conversions? We have some simple exercises in organic chemistry which involve the completing equations, but you can combine many steps to try and see how you can prepare compounds. So you will try to prepare CH3CH2 chlorine, to prepare this aldehyde ethanol from CH3CH2 chlorine. Starting from 2-bromobutane, you will prepare butanone. And starting from 1-chlorobutane, you will prepare propanol. Those are some of the challenging questions we can have in organic chemistry. So let me thank you very much for your attention and your participation, and I hope to see you next time, safe and sound, for the next lesson. Thank you very much.